Okay, hello everyone. Thank you for tuning into my talk for Decode 2020 entitled Pitfalls of OSS and IoT. My name is Ricky Lawshae, and let's get started. So, who is Ricky Lawshae, you may be asking? Well, I am a senior security researcher for the Advanced Security Research team at Trim Micro. Our team is split down the middle, with half of us focused on machine learning as it relates to security, and the other half, the half that I'm on, focused more on offensive research and making things more secure through vulnerability hunting and things like that. I've been with this team for about 7 years now, and during that time, I've found and disclosed around 50 or 60 different vulnerabilities in various devices. I also very much enjoy speaking at conferences around the world, but this is actually my first time doing it virtually, which I have to say definitely has its pluses and minuses. I'm on my third take of trying to record this video so far, so we'll see if this one's a keeper. Okay, before we get going, I wanted to make sure I made a couple of things clear up front so that I don't give the wrong impression with this talk. First, do I have something against open source? I actually love open source. I've been an avid Linux user since my days of going to the Houston Linux Users Group in high school. I use Linux on my work machine, despite the complaints of our company's IT department. I have contributed to a few different open source projects, mainly Metasploit. I also have a personal GitHub repo where I post my own projects and code as often as I can. There's lots of demo code from my previous talks up on my GitHub, as well as a few little, throwaway projects that I just do for fun. So yeah, this is not some kind of personal vendetta talk against open source. Second, am I trying to say that proprietary software is somehow inherently more secure than open source? I actually think the opposite is true, as I think many people do. The more open and accessible a code base is, the more people can examine it. The more people examine it, the more issues they find, and the more issues they find, the more issues get fixed. And the software becomes more secure as a result. So if you're trying to rely only on hiding your source code as your means of security, then you aren't actually securing anything, Security through obscurity never works. Basically, all I'm trying to do with this talk is point out some pretty common, easy to make mistakes that I've noticed when vendors just dive headfirst into the world of open source software when they're not really prepared. And hopefully I'll be able to help others not make the same mistakes in the future. With that, let's talk about the main reasons as I see them that vendors decide that open source is the right choice for their IoT devices. The biggest benefit to open source software over proprietary is definitely cost. We'll talk about this more in a bit, but when vendors are faced with a choice between paying huge licensing fees and development costs versus what is often just given away for free, free is obviously going to be the more tempting option. Another major reason for going with open source, especially when it comes to IoT, is the fact that it is super easy to take existing code and modify it to suit your needs. There are even lots of frameworks out there for various classes of devices that only require a moderate amount of customization to get them working. It really eases development efforts. A third benefit, which I'm not sure is an actual selling point for anyone but me, is the fact that open source is much easier to audit. You can make sure that the third-party libraries you're depending on are actually secure and even patch them yourself if needed. There's way less need for reverse engineering. It just cuts way down on time. It's way easier. Okay, but in order to actually reap the rewards of these benefits, you really have to know what you're doing with open source. I always like to describe it as the difference between standard transmission versus automatic transmission. Like, yes, you can save money going with the stick shift, and yes, you get way more control over how things run. But you also have way more room to totally screw up your car if you're not doing it right. In other words, Spider-Man said it best: with great power comes great responsibility. So that leads me to problem one, which I have called fork it and forget it. Now, as you probably know, a fairly common practice in the open source world is making a copy of a code base to take it in a new direction. This is referred to as forking the project, and it's especially common in instances where a project has died or isn't being actively supported or developed anymore. Or maybe you just want to take the project in a new direction or add new features that the original owners didn't want to sign off on. In either case, it's entirely legit, assuming the licenses of the original project allow for it and are still in place and whatnot. However, what many people don't seem to realize is that the original project may have had some serious issues already that no one had found yet. And those issues now become your issues. You kind of have to take on all of the baggage of the old project when you decide to make it your own. You also need to keep following the original project, especially if it is still active, to make sure you copy over any fixes that may come in when those issues do get found, especially for security vulnerabilities. So let's take the case of Realtek's UPnP libraries, for example. So Realtek is a company that makes integrated circuits for a variety of use cases. They make chips for audio, video, Bluetooth, and they're especially known for networking. They make some of the most commonly used network chipsets around. If you've ever bought an Ethernet card or a consumer grade router, it probably had a Realtek chipset under the hood. So because Realtek wants their chipsets to be as ubiquitous as possible, they create SDKs, software development kits, to make things easier to integrate for developers. And included in their SDK for their routers was a library for handling UPnP requests called Mini IGD. The IGD stands for Internet Gateway Device. It basically allows you to handle port mapping and other things via UPnP requests. Now, I can't say this with 100% certainty, but when I was taking a closer look at Mini IGD, it appeared that it was actually forked from an open source library called Mini UPnPD. There were actually still places in the code where they hadn't changed the word Mini UPnPD to their Realtek banner. Again, this may have been completely above board and wouldn't have been a problem regardless. But in 2013, a command injection vulnerability was found in Mini UPnPD's add port mapping functionality. It was fixed in the original project, but that fix was not carried over into Mini IGD. So jump forward to 2014, and I'm working on a conference talk on the UPnP and SOAP protocols. As part of that project, I wrote a fuzzer for the SOAP protocol, and I basically only worked on it until I got it to the point where I was able to run it against a device. The first device I tried it against was a a cheap TrendNet Wi-Fi router I had laying around, and it immediately found this command injection vuln in the add port mapping command. So I and Josh Smith on the Zero Day Initiative team did some digging into the root cause of the bug and eventually tracked it down to the mini IGD library. After figuring out who was responsible for the bug, we reached out to Realtek, but we were ignored and ignored and ignored and ignored until finally in 2015, we had to go public with it since we had no other way of ensuring it got fixed. It got disclosed as CVE 2014-8361. And at this point, many different vendors finally took notice since they were all using the affected Realtek chipset for their routers, and they started to release fixes for their products. But the number of affected products was extremely large. And if you follow IoT botnet related news, that CVE probably sounded familiar to you because it actually ended up getting picked up by Mirai and basically every IoT botnet since. So that ended up being a pretty bad one. All right, let's talk about problem number 2, save costs at all cost. As I mentioned earlier, cost savings is probably the biggest motivator for moving to open source and IoT. Anything that can be done to keep the bottom line low and the profit margins high is going to be done. That's just the way business works. But in some cases, it's pretty obvious that cost was the only thought that was given. And there was no consideration whatsoever given to things like training or education on a new platform or development time or anything else. This is really the best explanation I can come up with for what happened with Crestron's touchscreen products. Crestron is a company that makes very high-end multimedia and IoT controllers. They're used everywhere from universities to hotels. They are used in like most of the hotels on the Las Vegas Strip, for example. They're even used in like government buildings and airports. And up until fairly recently, the vast majority of their products were Windows CE based. They were actually even awarded the Microsoft Global IoT Partner of the Year award in 2018. And on the Windows CE side, their products were relatively well developed. It was clear that they spent a long time honing their platform. But then when they suddenly made the change to Android and Linux-based products for their touchscreen tablet devices, they kind of lost their way a little bit. I don't know why they made this change, whether it was cheaper or easier. I don't know. But one thing that was immediately clear was that they spent as little time and effort as possible porting their functionality over from the Windows side. Everything that was developed from scratch before, they just punted straight to the Linux shell on the Linux and Android platforms. I found 22 unique command injection vulnerabilities in their Android tablets. Basically, anytime they took input from the user on the management console, it was done without any sanitization whatsoever. And all the services were running as root too. So all of those commands that I was injecting would get executed as the root user. I was able to use these vulnerabilities to silently enable the built-in webcam on the touchscreens to start streaming video and audio over RTSP, essentially turning them into remote spying devices. And these devices, they're intended to be used in like fancy boardrooms at big companies and stuff like that. So it's pretty dangerous from like corporate espionage type aspect. Also bad when you consider they're used in hotel rooms and stuff like that. Could be used for nefarious spying purposes. So anyways, these vulns all got lumped together and disclosed as CVE 2018-5553, 11.22.8, and 11.22.9. And they've all been fixed at this point, but I'm pretty sure there are probably other vulns in those devices because they really put as little development effort as they possibly could into them, from what I can tell. And just as a fun, quick side note, 2 of those vulnerabilities were actually coincidentally found around the same time as me by other researchers completely independently. And we all ended up sending them to Crestron within a month of each other. It's kind of funny, one of those funny quirks of the industry. Okay, so the last problem I'm going to talk about is kind of the opposite of problem 1, custom bugs. Again, as I said earlier, being able to make your own custom changes to existing code is a huge plus for open source software in IoT. You don't need to waste time reinventing the wheel for every device. You just take a code base or even a whole framework and make a few changes so it works. It cuts way down on development time and therefore also helps keep costs down. But again, unless you are careful and know what you're doing, your custom code could very easily contain its own vulnerabilities. It could be the most established, time-tested, well-vetted project around, but as soon as you start making your own changes, it is no longer time-tested and needs to be treated like a brand new project, which was exactly what happened with Microhard's Bullet LTE. Microhard is a company based in Canada that makes radio and cellular networking equipment for use in environments like point of sale and SCADA and oil and gas and things like that. Basically, they're meant to allow critical systems to be remotely managed. The Bullet LTE is their LTE device that takes Ethernet, serial, etc., and bridges it to cell networks via a SIM card so that devices can be reached anywhere in the world. And the Bullet LTE is actually based off of a custom implementation of OpenWRT. So OpenWRT is an open source router framework that has been around since 2004. It has a huge community around it and it's very well supported. But Microhard needed to make some changes in order to get the web management portal working the way they wanted. No big deal, that's pretty common. But as I was looking into it, however, I found that, surprise, surprise, their implementation of the ping command was vulnerable to yet another command injection vulnerability. So let me just say this real quick. If you take one thing away from this talk, make it this. Please, if you are developing an IoT device, don't put a ping tool in the web management portal. It is going to be vulnerable to command injection. I don't know why, it just always is. Okay, so anyways, so that vulnerability was just a post-auth vuln, meaning I had to be signed in as a valid user in order to exploit it, which is not as impressive as it would be without needing to log in. So I decided to take a look at the auth routine to see if I could find a bypass. Now, because this device was based on OpenWRT, it used UHTTPD as its web server. And at first glance, it seems like Microhard was using the stock implementation of UHTTPD's basic auth routine, which would have been fine, basic auth is not super secure in and of itself and wouldn't stop credentials from being sniffed by a man-in-the-middle attack or something like that. But the UHTTPD implementation itself is fairly rock solid from what I can tell. But the microhard version, it did have one small change compared to the original. In order to accomplish logging out, microhard wanted to be able to send logout as the username and password. And to check for the string, they added a statically sized 256 byte buffer and used strcpy to copy what was sent in the auth header into it. But the contents of the auth header, of course, could be much larger than 256 bytes. And there was no additional check added by microhard to ensure that the data being fed into the new buffer would actually fit. So if an auth header was sent that was larger than 256 bytes, it would run past the end of the allocated buffer and start overwriting subsequent values in the memory stack. So in other words, this one small change ended up leading to a textbook pre-auth buffer overflow vulnerability, which I was able to exploit for root access without needing a valid user account. I will say in their defense, though, that this device did actually have some moderate mitigations in place to protect against exactly this type of vulnerability. So that was a point in their favor, but they weren't actually enough to stop me in the end. So this vuln has also been fixed as of July of this year, and was just recently disclosed as CVE 2020-17407. This one is actually so new that you all are some of the first people to be hearing about it. I should actually have a blog post coming out soon, if it hasn't already come out by the time this conference happens. That will have full technical details of this vuln, as well as some details on other things I found while I was looking at the Bullet LTE. So look forward to that. Okay, so this is usually when I would show some demos of the exploits in action, but due to the time constraints and the amount of info that I wanted to get across, I didn't really have time for a section of demos. The first two examples I gave in this talk were both used in previous talks of mine and did have live demos in those talks. So you can just go and watch them there if you're super curious. Otherwise, if you want to reach out to me, I'd be more than happy to see if I can figure something out for showing more detail or demos at a later time. But for now, let's just go ahead and wrap this up. So in conclusion, as I see it, IoT right now is about where computers were in the late 90s, early 2000s. It's everywhere, super ingrained in our everyday lives, and vendors are finally starting to get the picture that securing these devices is important, and incidents have actual, tangible, potentially costly impacts. But at the same time, they haven't quite gotten to that maturity point where they're doing a lot about it proactively. They're not doing as much as they should be doing yet. And until they do, the botnets and the ransomware attacks will keep taking advantage. So what needs to be done is IoT vendors need to implement a mature, secure development lifecycle where they're security conscious every step of the way from the very beginning. They need to devote the time and resources to properly train their teams on open source development best practices. And they need to be both proactive and reactive in keeping on top of security updates for all parts of their platform. That includes like third-party libraries and things like that. Anything they use in their platform, they need to keep on top of updates for it and keep on top of doing security audits themselves, as well as getting outside audits done. Basically, all of the things that normal software companies have to do. Now, do I think that's ever actually going to happen, though? Not really. This is probably the most depressing part of my talk, because if they actually do all the things they need to do in order to make their products properly secure, it would probably destroy those coveted profit margins and get rid of a lot of the, the reasons for going open source in the first place. And it just seems more like IoT devices are being designed nowadays to be like, consumable and replaceable rather than robust and long lasting. I don't really like that trend, and I hope it gets better, but I'm not sure if it will. So I guess we'll just have to wait and see. Okay, that's the end. Thank you very much for coming to my talk. Feel free to follow me on Twitter or reach out if you have any questions. Thank you very much.